It's the SDG Podcast. Before we get started, you can check us out on the web at solutiondesign.com/podcast or find us on all the social medias, LinkedIn, Twitter, Facebook, and Instagram at Solution Design Group. Microwave. We're podcasting again, and let's go around the horn and say hello.
Hi, I'm Chad Jetner.
Hello, I am Master Technomancer Akila Cavo.
Hi, I'm Kyle Bacher, and I'm also here. We're going to talk about generative AI today.
Yeah.
And we had a fun time chatting about it, learning about it yesterday.
I wish we had a whiteboard right here, so I can redraw that the math.
I can turn around, you can do it on my back.
I do have a whiteboard I could bring in here, but I'm not going to. Just think of like boxes and lines, and I like it though, starting with the sentence.
Yeah, and I think by the end of it, it started to look like that Charlie Day meme from It's Always Sunny, right? Where he's like conspiracies all over the place. Yeah, when you start to draw that stuff out, it gets really complicated really fast. But the main thing to take away from it is, so we're talking about training models, right? So generative AI, we start with a data set, and we go from a data set to a model, and then you train your model off of a data set, and I was trying to draw out like kind of the math that's involved in tokenizing individual words and individual sentences and the end of string function, like how all of that comes up and gets tied together, because we don't send an AI model words, we send it numbers, right? When we actually do this, it's only operating on numbers. So for every generative idea that we have to turn something into a number. So for images, it's relatively simple, right? You got an RGB code, and that can be a number that represents this pixel.
Okay.
For words, we have to tokenize them, and then we have to come up with a formula, and it's all linear algebra, if you guys remember that. That's the X1 notation, X2 notation, X3 notation, all that stuff, right? So it's all linear algebra that you bring up and up and up, like you're talking about a single word, and you give it a value, and then you have your you have some functions up here that all cycles through. You assign weights in between everything, and the weights are the secret sauce. That's what these generative models operate on. Is like once you have a weight, then you can say this is important and this isn't, and you can do some fun math around.
Now, and then there's what is the attenuation piece of it? Is that where it's using the weight and looking at everything else and kind of reorganizing, like modifying the weight itself?
Yep. So the attenuation is it uses the weight, and then it does modify itself for the next time, kind of, right? But what we're really trying to figure out is a way to compare words next to each other, to like how frequently does that occur, right? So I can't repeat the phrase I used yesterday in the demonstration, but like if you just had the phrase "let's go," right?
Yeah.
Let's and go, and then how often are those two together? Or a more common one is like, I took the pizza out of the oven, it was hot, right? What you try to do with some of these formulas is assign the word "it" to the thing that it's referring to in the previous stanza, right? So that's where, when I was trying to draw yesterday, is you have your words down here, you have your sentences. You try to build out relationships from one word to the next, forward and backwards.
Right.
And then you try to come up with a formula, like a mathematical formula, that will identify all of those relationships. And so I drew out a simple neural network yesterday on the whiteboard, and that just had two functions above the words with the weights in between, right? What folks are really doing, like OpenAI and Meta and everybody else, they have hundreds, if not thousands, of functions above every sentence. And so just think about the math involved and the computational power that's required to actually satisfy some of these equations. And that's why we're using, for AI models, this is why we use GPUs instead of CPUs, because GPUs are really good at simultaneous multi-core like crunching of hard numbers like that. Whereas a CPU is kind of, still great, but like you can still do it, but this is where GPU consumption is becoming such a scarcity, right? Because all of these companies...
Is this why like graphics cards, like higher-end graphics cards are so frickin' expensive?
Yeah, part of that is also because of how they get used in like crypto mining, because essentially if you're looking at a CPU versus a CPU is broken down in a way that they have smaller cores that's meant to have a lot of smaller things very quickly ready to access in your L1, L2, L3 memory streams, which is stuff that's supposed to be as close as possible, things you're always going to use. But GPUs, on the other hand, and we're talking like maybe a couple megabytes or gigabytes of like processing power on that, but when you're talking about a GPU, you're now running like a 16 gigabyte graphics card or something like that, you're able to, as you said, parallel a lot of number crunching because it's meant to do larger data sets, larger computational things that kind of follow in those work streams versus stuff on the motherboard or on the graphics card, or excuse me, CPU. Okay. On the CPU that's meant to be like operating stuff as that stuff can operate as quick as possible, as close to where it's meant to be.
Excellent.
So it's all math, right?
Yes.
Yeah.
It's I used the example yesterday. So Facebook, or Meta, they just released a new model, I don't know but within the last few months, called Llama 2. And it was trained on over 2 trillion tokens, which is an absurdum. I mean, it's basically all of human history, like all the knowledge, everything.
Right.
Actually, it's kind of cool because they have a licensing model for it. So you can use it, right? You can actually download it and use it. The only restriction that they have on the license there is that you can't use it for commercial purposes if, at the time of download, your company is worth more than $7 billion. Right? Like, I think that's... was it something?
Twitter can't use it.
Well, no, actually, Twitter probably can right now. I think they really could.
At the time of download.
Yeah. If they downloaded it today, they're probably good. But I think it was they're specifically trying to block out competitors like Snapchat and everybody else from profiting off of this thing.
Yeah.
But literally everybody else can use it. And they...
Well, to your point, when they first published that out, they did publish out the data set first without any of the weights. When that first came out, Llama 2, it was out for a little bit, but then they only had a certain amount of researchers that they distribute out the weights to.
Which, like we said yesterday, the weights are the secret sauce, right? Like that's what actually tells you how these tokens, how these words relate to each other, and which ones are important, which ones aren't. So yeah, I remember that they just published the model, and they're like, "Hey, there you go," and then everybody's like, "Well, can I see?" Like, no.
So the functions that right above these things that they have so many of, is that part of a neural network, or are those their own like neural columns? Yeah,
I think you could kind of consider the entire model like a big neural network, right? And it's just everything connecting and relating to itself, and tying back to itself. And one of the interesting things that they do is how far back they go, right? Like we tokenized via one sentence, right? But if you're saying like, what did I do the other day? I was like, hey, write me a new Rick and Morty episode, but also kind of like in the style of Sanford and Sons, right?
Okay.
So that's one where like, okay, how do you do that? How would it possibly, and it actually kind of did, right? Like, because I'm a huge Red Fox guy. And so it was actually able to like kind of put together a script, a spec script that looked real, and actually like it was kind of interesting. I still have it on my laptop. It's great. Yeah. But like that involves
the next podcast will be a live script reading of that.
Yeah. That was, but to do that, right? You can't just examine one sentence. You have to examine an entire, script or an entire thing, and you have to digest that. And that's where those simple little neural net that I put up on the board yesterday was like ridiculously oversimplified. Right.
Yeah. I mean, there's probably huge algorithms in all of it.
With these neural nets that get built, there's essentially what's called like the hidden layers that sit in between that. And in most of the examples that we end up seeing, where we're like, all right, there's a few hidden layers here, but when you're looking at these large of data sets, there is so many thousands of layers of hidden layers that are operating in between some of these things, especially in image recognition, that we do not see. And there's work being done to try and put some explanations behind some of these layers, but ultimately it is a little bit of a black box where it's like we've got the input, a whole lot of hidden layers that are doing the computational bits that get kind of generated through unsupervised learning, and then the outputs of this being able to see kind of where it is with maybe, if we're doing good enough, a little bit of explanation to it. But a lot of the times, that's where a lot of the active work right now is being done, and these neural nets is trying to make them more explanative or expressive about what they're doing, especially when it comes to things that have to, explain bias, especially when that's coming from bias in the original data set, whether that is someone just only, uploading particular stuff that is, like hand dryers, original hand dryers, in those.
I remember that. Yes, yeah. I remember that conversation.
We were having a little bit of conversation.
Was that in the during the talk, or did we have that conversation at the bar?
I think that was a conversation that happened at the bar because we kept talking about it. We liked our conversation so much, we went to the bar and kept talking about it.
So, if there's 1,000 different types of a thing, and you're only plugging in one of those, you're biasing it toward that thing because you're putting all that weight to it. So, is that correct?
Yeah, I mean, not to get too, I don't want to get this to veer off, but imagine a software developer, right? Close your eyes and think of a software developer. You're probably thinking of a middle-aged white guy, right? That's writing software, and if you're doing like BIOSes for a hand dryer or whatever, you're going to test it with your hands. Well, not everybody's hands look the same, right? So hand dryers, the Dyson or the what was the?
I don't think we got and described or established the brand.
Bad.
Bad, but they didn't recognize certain ethnicities' hands, right? Because they were trained to recognize.
Oh, they have the you put them in, it recognizes those are hands, and it turns on.
Yeah, exactly.
So you can't just have a photo gate in there that if you break it, it turns on. They
and it's not even
a scanner thing.
Yeah, and most of the time it's not even necessarily just a photo. It is some sort of light emitter that's detecting the light that's coming back.
Right.
But it's trained on light skin tones, so things with darker pigment don't recognize in this trained model as something that would come back as a hand.
And that's that's a real world example of this going bad. But think about the data that we're training the models on, right? Like a lot of that data was written by historically middle-aged white guys.
Well, yeah,
they were the people that got published, right? So we're training all the models on this, and then the output of the models are going to have that bias built into it. Okay, how do we fix that? As a middle-aged white guy, I have no idea.
And then when we talk about large language models at that too, we can also start talking about language bias. There is the most large amount of information that this has been trained on in English. Second to that is German. And then after that, it starts getting worse and worse at being able to translate or talk about logic in these different languages, because it's mostly built on, just a lot of American documentation in English, and then also the Germans having to document everything as they do.
They're like gnomes.
So there's just a lot of that on it. So if you're trying to work with those languages or translate between them, they work really well. But as you start getting to more and more obscure languages, it starts to fall flat. Where, there's still some models being developed on very specific languages being fed just a data set of that, and they work well. But these super big, large, general ones will, of course, only kind of work on the middle cusp of what the median of the data that's fed in on. It doesn't work great for the outlier stuff.
And think about that in terms of like what I demonstrated yesterday. That simple neural network wouldn't even work with a kanji character set or Chinese characters or like all of that stuff. Like it relies on tokenization and it relies on the English language, right? And how do you train that with an entirely different, not just alphabet, but Sanskrit? How do you do that? It's
and then when you start talking about the theological constructs that go behind that language and how they assemble those words and what they mean and the different contexts that a single word can have based on the dictation or things that you put into it. How do you then start extrapolating that into a model and have that comparable to English?
Well, you're looking at there's different words for things that mean different things used in different contexts. And then those words get translated incorrectly.
Yeah.
And then that gets translated, and
I mean, this is a software development problem,
right.
Bigger than AI, right? Because software, it's an American kind of like, most of it was an American invention, right?
Yeah.
And so we build software using English words, right?
Yeah.
If the whole practice of software development was invented in China, holy crap, we'd be screwed, right? Because we'd all have to learn how to code in China, but we don't, right? Everybody has to learn a little bit of English in order to write any kind of software, right? And I know there's...
I will challenge that a tiny bit, because I know in Japan they write code in Japanese.
They do. I was just gonna say, like, I've seen it done in other ways, but like, by and large, you're writing, supportable code in using English words, in using, our style, right?
Right.
So
that's kind of at the the quality of the data set interacting with and how the code is written. Is that go around provenance then, if because it's all English and slanted that way, does that change the provenance of the data?
so the data provenance is like literally what are you seeding your data set with, right?
Right.
Like, where does this come from?
Yeah.
Are you using copyrighted works? Are you using is it actually fair use if you train your data set with a book that you bought? All of these legal issues actually I think are pretty much settled, right? So like there's case law that says if you use copyrighted works to like build up a catalog, a search catalog or something. Google Books did this. We talked about this a few weeks ago, right?
Yeah.
That's actually a fair use of copyrighted works, right?
Right.
You can actually do that. They call it transformative, right? Like if you're not taking a book and then just like publishing it online, or taking a book and then like writing a new story based on those exact same characters, it's a transformative use case. And I think a lot of the AI stuff is going to be exactly the same thing. It's going to be a transformative use case of an original work to use that as an input into a data set that you're going to train a model on.
Right.
So I think all of it's going to come down to like the courts are probably going to side with the software and say, yeah, it's not an infringement if you use copyrighted stuff to,
if it is transformed.
Yeah. Now,
And not like replicated.
Yeah, like you might use that. Well, that's where it gets goofy, right? Because if you use an entire library of copyrighted information, like you upload all the Sherlock Holmes books as a data set, and then you say, write me a new Sherlock Holmes book, right? That might be a little like...
Yeah.
Because the person could say that you are now infringing on my ability to capitalize on my own IP. And so like that could be like a Disney situation where they say, no, you're infringing on that.
And maybe Sherlock is a bad example because that's all open, that's all public now anyway, but like Star Wars is a great example, or Marvel is a great example.
Right.
You can't...
Or, like, I think, honestly, those are great big IPs that, like, if people, like, I mean, no matter what, there's always going to be bootleg Marvel. Always. Like, that's not, like, regardless of AI, that's going to be a thing. I think where it's really going to hurt is smaller artists, smaller authors, and things like that might have a particular cult following, but then someone trying to then capitalize on that and try and make more of that just to make a quick buck. And I think that's where some of the more the pain felt by everyday people are going to be, is kind of more so on like that smaller scale.
Yeah.
And that's going to be a lot harder for those people to prove out and say like, now this person is copying my art style. And like, even if somebody were to do that, and like there is like legal precedence for like people like legitimately copying other people's art styles and then, having legitimate litigation brought against them for impeding on the other person's right to profit off of their own work.
Yeah.
Because they're taking the market share away from them being able to do that.
I want to go from Chad's statement yesterday of he built that out and said, this is crazy complicated, you never want to do this.
Right. Yeah.
Like,
you probably
you're never going to have, where are we going to start? At what level are we going to start? Because there's layers upon layers, and then because you've got the language models, but then you've got a thing like ChatGPT, which is
Yeah, so you're going to start at, you're going to let somebody else train a model, right? Like let somebody else do that, and that's where Hugging Face comes in. It's like GitHub for AI or for ML, right?
Right.
So go to Hugging Face, find a model that you like, be it Llama, be it BERT, like whatever your use case is. I don't know that I said that eloquently yesterday, but one of the ideas is before you even start working with any of this, figure out what you want to do, right? Do I want to just generate text? Do I want to generate images? Do I want to generate what, right? Like, what are you trying to accomplish? And start there and then work your way back to, okay, what are the different models that actually satisfy this use case? So for text, you're going to probably do GPT-3, you're going to use BERT, or you're going to use Llama, or there's like dozens of them out there. And the one thing that Hugging Face does well is they give you like a little preview, one of Providence, two of like, here's we prompt it and see if this is the output. Like it's all built into their platform. We're going to start, I think, for practical purposes, and as consultants, we would probably start there. Let's find a model that baselines the use case that we're looking for, and then build applications on top of that. And then fine-tune it if we want to, right? And fine-tuning your model is what probably adds your secret sauce to, Yeah. Because models, they're going to be trained. And they're going to be trained, and it's almost like they're going to be caught in amber at the moment they're trained. You need to fine-tune them to keep them fresh. And then you specifically need to fine-tune them in order to get like whatever your business case, or whatever your use case is. You want to get that information into the model too to make it a little bit more relevant for what you're trying to build. So like if I were to build a baseball application, I would want to train it with, current rosters, current stats, maybe current everything, so that I could ask questions about when was the last time Byron Buxton played center field? It was 367 days now, which sucks.
Where I think this is going to touch in, for at least where I'm at in the quality space, is there's kind of already a few tools out there doing some generative stuff in AI for doing generative AI testing, writing generative tests for that. And so some names in that is like Test.ai, Functionize, and AppVance. And kind of what some of those tools do is like we're going to look at your server logs, your production server logs, and we're going to then have this AI that's been trained on the blueprint of what your website does. We're going to then generate a whole bunch of test cases. And now it's a whole bunch of test cases with data that's been generated with it to kind of go through all this stuff. And that's, again, kind of like what we have been seeing, where it's like, all right, we're going to generate an image. We're going to generate a whole book. It's like generating the output of all of these tests. But there's still some problems of it's like, okay, we've generated the output, but what does this mean? What does this test case mean? So while right now we're in a space where we're trying to use it to speed up test case writing, that's not, I think, the use case that is helpful in quality. It's how can we use it to better tie requirements to what our tests are, and kind of developing it off of that versus trying to do the quick, easy route of, putting everything and then trying to make sense of what we generate. Because with that, we end up having 5,000 test cases. What do any of these mean if one of them fails?
You had a cool use case the other day where it was using it to generate data, right? Like for like if you're working on a healthcare application, you don't necessarily have access to real data. You have to make that up yourself. And using a basic LLM to like just generate you, hey, create 1 million records for people with 1 million different problems, right? That would be awesome. I hadn't thought about that until you said that, but that's actually like...
For test data management, it will be revolutionary, because that's been one of the biggest hurdles in test data management is you have either your real data or you have synthetic data, and that real production data can have PHI, it can be an issue. So sometimes what people do with that is they mask it, so they just try and throw something on it, but we're now going to change it to something else, and now this person's name is Gold87892. So it's like, what is this going to do? Is this still expressive? No, it's still garbage. And you can't always make sure that you still got everything that's PHI. You can miss stuff.
I wonder what happens when somebody, like, honestly, AI generated healthcare information, because I'm sure it's going to be a thing. But eventually,
that's going to be a big service. That's going to be a big industry thing. But
eventually, you're going to run across an AI generated model that accidentally contains a real person's name, and you're like, oh, hey, how's that rash doing, Bob? I saw it in the test data set. Hey,
it will. So, when I look at the applications of that stuff, that it's generative AI, that it's kicking out content, and you're asking it questions, and you're giving it what it needs to answer you.
Give it the abstraction.
Right.
One of the biggest things is going to be how can you define your abstraction of what you're looking for?
Right.
In the case of test data, you have to know your application and you have to know your data model for it. Here is what our user records look like, and these are all the fields that make it important. And here is an example of, say, a formulary user and a general user, and like these are what make these special. You feed it that abstraction, then it does all the other generation of filling in the blanks.
And I think Shui had a great example yesterday. Like he said he actually did use it to generate, what was it, like this massive CSV or something that he was working with.
Oh yeah, the code that goes through and chops it up, and
he just used AI and it worked.
I've used it to write PowerShell script, and I have to go in and get rid of all the old methods that no longer work and put in the new ones, but it gives you a starting point. I look at this whole thing like a personal assistant and prosthetic brain and coworker, and like it's going to be you're going to partner with this to do things, and it's going to jumpstart you. It's not going to like run your life. But it's going to be like when you're using Photoshop, you can talk to it and go, I need this kind of brush, and it changes smaller. You're giving it little adjustments along the way, and it's giving you what you need. I think the content management implications for this are incredible. Having worked with organization after organization to try to organize their stuff and make it so it's like relevant, and when they've saved everything, for something to be able to scan through all of it and learn what it is and be able to categorize it and like find the duplicates, clean it up, get rid of the old stuff, like that could go in and do what takes a year in like a week. Implementing that structure then might be the output where your team has to go in and do some of that work. But I look at that as a huge win because people don't want to do that. Asking someone to clean up their stuff, oh my God.
I'm a child. I don't want to put my toys away.
No.
I'm still using them. They're all on the floor for a reason. What if I want to play with that?
I might need that someday. But I look at those possibilities. How do you engage with it then? You talked about how you tie in it on a development level, how you tie into it on a QA level. What other segments of our industry do you think can tie into it as well?
I think that, at least from my perspective, maintenance as part of it, if you define your requirements well enough and that abstraction of how you're interacting with it, the maintenance half of it can help be trained because you have self-healing code because it can look at the output, recognize what needs to be changed, and then get back to green because you have the requirements it needs to get to. It can determine the path of correction for itself and even pass it back. I think in a previous conversation I brought up that Facebook has a tool that they internalized and put out for doing AI suggestions on how to fix and improve code. And they said that 45% of the time or things like that, developers actually took it, and in those cases there was like at least like 13% of the suggestions that came out that were syntaxually exactly the same as what their senior developers would write and put out because it's trained on their code. And I think that that's really interesting because it's like this thing is able to look at a problem, not even necessarily presented with one, like in a code review context, and say, here's a better way of accomplishing this. And pulling in suggestions that way.
There are going to be things like, we use SmartCube where I'm at, and that's a tool that just goes and inspects all your code and looks for like opportunities for improvement, right? Like cognitive complexity scores. It gives to like if you got a method that's 1,000 lines long, it's going to say, hey, maybe right now it's going to say, hey, maybe divvy this up a little bit. But right now it's kind of stupid, right? It's just like, hey, this method is 1,000 lines long, and I can tell because there's the opening curly and the bottom curly, and there's that much space in between there. Well, it might be 1,000 line long for a very good reason. I think the AI models that are going to be able to examine this stuff a little bit better than the static analysis that we have now is going to help the maintainability of a lot of these older code bases as well, right? Like if you actually have an AI model that examines your your organization's GitHub repos. Like, go through all of them and start telling me opportunities for improvement, right? Like, tell me how these relate to each other. Tell me how these, like, which projects are calling which other projects. Like, I'm at an organization where we literally have hundreds, if not thousands, of distinct GitHub projects out there, right? Like, distinct things in GitHub. Well, holy crap, if you could put an AI model on that and say, find me the relationships between these, and build out like a graph or build out a diagram of how this stuff is all connected. The amount of business intelligence you would gain from that, like, it just doesn't exist today, right? Like, right now, we do our darndest to document, and keep our Visio documents up to date and all the other stuff. There's a future where that might just be like examine.sh, GitHub repo, done.
Yeah. Well, on the business intelligence side of things, I used to be asked to build a lot of dashboards. We really want a dashboard that's going to tell us everything we need to know.
Yeah.
And then, okay, what do you want on that dashboard? I don't know.
I think that the implications for dashboards is also huge too. Because, essentially, you just have to point it to the endpoint that's supplying that information. Right. It knows generally just from how much code is out there how to interact with that. Yeah. And then you can just pair that up with something like a view component for whatever pre-built little graphs, charts, anything you want to share. When you can just easily build a page for
and having it like examine your data and then telling you what the important numbers are. These are the actual KPIs that you need to have.
Now that one I feel might not be as quick around the corner, because I think that that's still looking at AI to try and tell you like the output of what's important. And sometimes it can do good at that, but I think most of the time where it does best is where you as a business person can define the value that you want, and then you find the right model to get that value out of it.
Or maybe it just gives you a big menu of what it can tell you. Yeah. Based on what you fed it. And then you can pick and choose, and you evaluate that and add that piece to it.
And it takes the minutia of chopping up, an API response and also the CSV document. That's two different data points feeding into this. It takes out the minutia of having to like program everything for that, because it can know how to cut and crop up that information.
So what is the Chat GPT? What's the chat piece of it? What is that layer doing with that language model? Because I know it's telling me it's not going to answer because it's a large language model. I'm just a simple caveman. I don't know that.
So I think that is just, that's a brand on top of the model, right? Yeah. And it's literally just, all that is the prompt, right? It's like the Google search bar, but for an AI. Yeah. That's the chat part of ChatGPT.
So what's the prompting? What is it changing between the prompt and the language model, and what's it changing? Like, what's it doing with that both ways?
So I think the prompt part, it's also like an NLP, like a natural language processor. Like, it tries to infer and it tries to tokenize your prompts into the model. It does it both ways, right? So I'm prompted this way. It's going to turn your prompt into a string of numbers, and it's going to feed that into this language model, and it's going to say, hey, solve for this, right? This is the X, solve for X. Now, prompting ChatGPT doesn't necessarily affect the actual language model, right? Like, every time you prompt it, it doesn't change the model at all. Right. But it does create this tangential data set over here that says, here's all my prompts. Like, here's what everybody's asking, here's the prompts, here's the responses. Right. And when you prompt ChatGPT, in the UI, you get one response. But if you were to use the API, they actually give you the option to say, give me 5 responses, right? Like, what are your top 5 guesses as to what I'm asking you, right? Your top 5 answers to these prompts. So you can configure all of that. And you can also configure kind of this chaos mode, right? Where it's like, be less certain about your response, right? Like, basically you tell ChatGPT to not be so uptight, right? Right, yeah. Like, loosen up a little bit, have a drink, and then answer me, right? You can literally do that via the API. You can't give it a drink, but you can get it a little drunk
I'm gonna try.
Yeah, that's a good weekend.
Pour it on the server.
Speaking of,
Well, I think,
do I have a hole in my glass? Like, what's going on?
yeah, you do.
I watched it.
You look at the implications of that, like then going to some other version of it
Yeah.
is doing something else. But to me, it's the implication of expressing the response with authority, with voiced like that, voiced like, this is the thing, this is the answer to your question.
Yeah, kind of.
Instead of saying, well, this could be the answer to your question based on this other stuff.
Yeah, I mean, yeah, but I think the more important thing is like it's a language model, right? Like it
Right.
outputs. I think one of the goals isn't necessarily that it outputs accurate answers. It's its ability to output just the English language in a way that makes sense.
Yeah.
In and of itself is remarkable, right?
Oh, I'm
then
blown away by it. I use
Yeah.
it all the time to like write poetry and
Yeah, and then to and then all the other use cases for it, right? Like to output code. Like I said yesterday, I love using it to give me boilerplate starter projects, right? It's
Yeah.
a great thing that it's really really good at that. But the model is always going to be trained on months old information, so it's never going to be Google. Really, you're not going to go to ChatGPT and say, "Hey, let me know what current events are," or whatever, right? It can generate code. It can do sentiment analysis, like summarize this article for me, or is this a good review or a bad review? Like tell me without looking at the stars. And that's what it's going to continue to be great at. Not necessarily, hey, give me an accurate answer and voice your response confidently. Like I don't care if it's confident or unsure. That's what I was talking about yesterday. It's just going to make you. I mean, if you're a dummy, you're still going to be a dummy with ChatGPT. Just part of your idiocy is going to be artificial instead of, natural.
And it's going to make your ability to spread that,
Yeah.
to generate,
Yes.
and fill the room.
Yeah. That sucks so bad.
That's one thing that I am generally maybe a little bit worried about for the future. I mean, I know that it's going to be great that there's going to be a lot of transformative use. Exactly what you said. It's not going to be Google, and ChatGPT isn't going to necessarily try and hit that, but people will use these tools to then build other things on top of it, like implementing their own model at Google to make asking and understanding questions sound more human. We always just go ahead. For a long time, there had to be a little bit of, acumen to trying to find what you wanted on Google. But over time, they've made it better and better that you can just ask it like, well, what is blank, blank, blank? And then like ask it like a human and it will try and understand what you'll do. And I think it's going to get better at that using layering on top of these.
Yeah, oh, for sure, yeah.
And that's just going to get implemented into more and more of our tools, more and more of our everyday work streams. That's just going to
I think that's
it's intelligence of just like helping you find what you need or
it's
helping
be built into
generate.
everything.
Yeah.
I don't necessarily want my car. I'm not nice. I don't need my car to talk to me and have a conversation with me.
Right.
But I think when you do have error codes or anything, like they're going to come out in a much more readable fashion than what we're used to.
Right.
I have a speculation for the future, a very strong one. I believe that we are all going to have our own personal assistants that will be more personal. Essentially, digitizations of ourselves or something that we like a whole lot that will be a trained AI model to help us, that will maybe try and follow our patterns or the things that we're looking for, that would maybe hop across different devices. So like it'd be on your phone, your computer, etc. It'd be like your personalized Cortana on Windows, except for it actually helps.
Yeah.
My thoughts are around, like my parting thoughts is I want to figure out like what the right way to interact with it is. Which is the tool I want to be using? What is the chat part that I want to be using? And because right now I'm just doing stuff with Chat GPT-4.
Mm-hmm.
I think part of this is part of what Apple's problem is going to be with the Vision Pro. It is a revolutionary piece of technology that we have not found all the use cases for yet. And we're in the Wild West of finding all of these things out.
Yeah, and I can't wait till we get past all the dumb ideas. Like, everybody that uses this wants to build a chatbot. Like, are you gonna build a chatbot? Yeah, nobody cares, right? Like, nobody wants that. But once we get to like the second and third wave of applications for this, I think it's gonna get a lot of fun. It's gonna be a lot of fun, at least for the text-based generation. I think we're gonna have a lot more fun with it than I have a chatbot. I have a, what was the Joaquin Phoenix movie where he had the exactly, he fell in love with his computer. Yeah, it's
a great.
Silly. Yeah.
I love that movie.
Yeah, but it was like maybe that's not really a thing.
No,
I hope not.
I don't.
There's already people falling in love with AI personalities and digitized. I mean, I think that's just part of the parasocial relationships that we build with
It's a coping mechanism.
Yeah.
Oh God.
But if we want to do,
it's an emotional support AI. It helps you, but.
I'm not ready for the implications of that. I'm not ready for the implications.
I'm more interested in like how I can use this to get up to another level of like productivity, quality in my work, problem solving. Like is there heavy lifting it can take on?
I just try and find. I mean, again, it does really well of defining the abstraction of what you want and specifying the output. You feed it the data in and it gives you the out. So if you ever need to do something where you, through language, numbers, what have you, transforming something from one format to another.
Right.
If you can define that abstraction, it does very well.
I asked it what the difference is in height between the world's tallest dwarf and the world's shortest giant. And it gave me 3 paragraphs of why it couldn't answer it. And then 2.5 feet.
I love that. I asked the generative AI to help with this episode, and it has encoded a special virus that you'll have to tune in next week to get the antidote for. Thank you all for coming in today.
So long, folks.
Yeah. Goodbye, everybody.
Solution Design Group is a digital product consultancy in Minneapolis. Check us out on the web at solutiondesign.com or look for us on Facebook, Twitter, LinkedIn, and Instagram at Solution Design Group.